Have you ever wondered if the universe we reside in is the only one out there? Enter the Multiverse Hypothesis, a captivating idea suggesting that our universe might just be a singular bubble in a vast, fizzing foam of countless universes. This exciting concept is not just a figment of science fiction, but has its roots embedded in the intricate equations of theoretical physics. Theories such as string theory and quantum gravity have alluded to the possibility of multiple universes, each with its own specific constants and physical laws. Imagine that, universes where the laws of gravity, light and time could be completely different from ours. This hypothesis is like opening up a cosmic Pandora's box, unveiling an infinite array of universes, each more unique than the last. So, if the multiverse hypothesis holds true, we are living in just one of infinite universes, each with its own unique set of rules and properties. Now, let's dive into the realm of quantum mechanics and its interpretation of our multiverse reality. The many worlds interpretation of quantum mechanics is a fascinating concept. It proposes that all possible outcomes of a quantum event are realized in a multitude of separate universes. Imagine flipping a coin, heads or tails, right? But in the many worlds interpretation, each outcome happens in a different universe. One universe where the coin lands heads, another where it lands tails. The universe, in a way, splits to accommodate each possibility. This interpretation stands out as it removes the need for wave function collapse, providing a deterministic view of quantum mechanics. The implications of this theory are profound, suggesting a near infinite set of parallel universes, each branching out from every quantum event. In essence, every decision, every random event, results in a universe split and the creation of a new parallel universe. Picture our universe as a bubble in an ocean of bubbles. Intriguing, isn't it? This is the concept behind the bubble universe model. Each bubble represents its own universe, birthed and developing in its unique quantum vacuum. This model is often tied to the idea of an eternal inflation multiverse, where new universes are ceaselessly forming, each with its own set of physical laws and constants. Now imagine what would happen if these universes, these bubbles, were to interact, even collide. Theoretical physicists suggest that such collisions could leave tangible imprints in the cosmic microwave background radiation, the afterglow of the Big Bang. These imprints could manifest as anomalous patterns or cold spots in the radiation, like cosmic bruises marking the sites of these interuniversal encounters. While evidence for these universe collisions remains elusive, the possibility opens up fascinating new areas for exploration and understanding. The multiverse isn't just a sea of universes, it's a sea of diverse, unique universes. Picture this. Universes with more dimensions than our own, universes with completely different physical laws, universes where the impossible becomes possible. It's almost like each universe is a unique experiment in the cosmic laboratory, each providing its own answers and posing its own questions. But beyond being a fascinating concept, the multiverse hypothesis could also hold the keys to some of the most profound puzzles in physics. Wondering why the constants of nature seem finely tuned for life? The multiverse could explain it. Puzzled by the nature of dark energy, the multiverse might have answers. Curious about the initial conditions of our universe? Look to the multiverse. The multiverse hypothesis isn't just a sci-fi concept. It's a scientific exploration that could answer some of the biggest questions about our universe and existence.